Alright, I'm here with problems 3, 4, 5, and 6 from your Geometry Chapter 6 practice test. Or the answer on Moodle for all these, but here's a couple explanations for these problems. Number 3 and 4, we have to describe the reflection and rotational symmetry of these figures. And number 3, we have this trapezoid. This trapezoid, isosceles trapezoid, at least it looks like an isosceles trapezoid, but it appears that it only has one line of symmetry, and that line of symmetry is right here. Because if we were to reflect this trapezoid over this red line, it would appear exactly the same, or if we folded this side over to the other side, it would appear exactly the same. So that's the only line of symmetry in this trapezoid, right straight down the middle there. The rotational symmetry, this has none. This trapezoid will not look as it appears here if we rotate it 360 degrees until we get right back to where we started. If we were to rotate this thing, it would not look like how it does right now until we were done rotating it 360 degrees. So in that case, we would say that this has no rotational symmetry at all, because we will never see the trapezoid oriented the way that it is now until we get it 360 degrees back around. Number 4 is a little bit different. The reflection symmetry here is in a variety of places. There's a line of symmetry here. There's a line of symmetry here. And here. And these aren't perfect, but I think we get the idea, hopefully anyway, with how these are. And all those lines should intersect right here in the middle. And there's one more right there. And these are the reflection symmetry lines for this figure, this circle with these triangles on the outside. So there's several symmetry lines there. I believe that there is 1, 2, 3, 4, 5, 6, 7, 8 altogether. 8 symmetry lines all drawn there. If we were to rotate this thing, starting here and then rotate it all the way around, we would see exactly this figure 8 times when each of these triangles were at the peak until this one got back all the way around. So we'd say that this figure has 8-fold rotational symmetry, because we would see exactly this figure as it appears here 8 times before we rotate this thing completely 360 degrees. Number 5, we have a triangle, ABC. We're told that it's an isosceles triangle with angle A congruent to angle B, and the side lengths are as shown. So we know that this angle right here and this angle here, A and B, are the same. And since these two angles are the same in this triangle, then these two side lengths, AC and BC, are also the same, because that's what makes an isosceles triangle an isosceles triangle. It has two base angles the same, then as a result the two side lengths are also the same. And we have to find x. Well, we know that this right here, 3x minus 1, side AC, is the same length as 2x plus 5, because it's an isosceles triangle. So if we're going to solve for x, we can then say that 3x minus 1 is equal to 2x plus 5, because these two things have to be the same, because it's an isosceles triangle. Once we have this set up, we are in a position to solve for x. So we can subtract 2x's on both sides, subtract 2x from the right-hand side, come over here, subtract 2x's here, 3x minus 2x is 1x, and these two x's on the right-hand side are gone because we subtracted them. And now we have x minus 1 equals 5. And if x minus 1 equals 5, we can add 1 to both sides, or just look at that and say, well, x must be 6. By adding 1 to both sides, the negative 1 goes away, and 5 plus 1 is 6. So when we have to find x, x is 6. And number 6, we have a figure shown below, and the following are true about this figure. We know that ZW is congruent to WY, so I'm going to make a couple tick marks there. ZW and WY are the same. That's what these little red marks mean. These two are the same, and as a result of that, what I see right here is an isosceles triangle, because these two side lengths are the same. So this triangle right here, we can call it WZY, this triangle that I'm outlining here, is an isosceles triangle. We are also told in this picture, I'm going to skip this sentence right here, we're also told that if angle Z is 38 degrees, find WYX, but I'm going to pay attention to this, if angle Z is 38 degrees, that's 38 degrees. And this is an isosceles triangle. And as a result of this being 38 degrees and these two side lengths being the same, these two angles must be the same, because this is 38 This must be 38 also, because this is an isosceles triangle. And now that I have those two angle measures, I can determine what this angle measure is, because there are 180 degrees in a triangle. So 38 and 38 would give us 76. This angle here, W, must be the remaining degrees to make it 180, so that means that this angle right here is 104. So I have this triangle here that's an isosceles triangle, and I know it's isosceles because we're told that these two things are the same. We're told that's 38, so that must be 38 also, and then that can be 104 because they add up to 180. If I know this is 104, this angle here, I can find this angle, because these two angles right here, this angle that's 104 and this angle here, are a linear pair. They're along the same straight line. We can assume that this is a straight line here. So I can find this angle measure because this and this add up to 180. And if this is 104 here, this angle here must be 76. Now that I have this, I'm going to go back to this sentence here. Side length WY, this side length here, is congruent to WX. That would be this side length here. So I can put a tick mark here and say, well, these two are the same. And now if I kind of look sideways a little bit, I can see that this triangle right here is an isosceles triangle because it has two equal sides. This side and this side are the same. I know this vertex angle here, 76. These two angles here have to be the same measure because this is an isosceles triangle. And I know that there are 180 degrees in this triangle. And I have 76 of those degrees accounted right here. So if it's 180 degrees all the way around, there's 76 here. If I do 180 minus 76, that's 104. So 104 degrees need to be split up amongst these two angles here. But those two angles are the same. So if we have 104 divided by 2, we get 52. So that angle must be 52. This angle must be 52 also, and all three of these will add up to 180, and they should because they're all angles of a triangle, of the same triangle. And now we're asked to find angle WYX. WYX is this angle right here. The angle that's formed from going to W, to Y, to X. This value right here, 52 degrees, is the angle measure of WYX.